Aloha, everyone. Well, you're all fed, and the coffee and the water is over there in case you need a picker-upper. But we are going to go ahead and get started with the business track this afternoon. So I would like to introduce you to our two speakers in our first session, Scott Fujieda, DataHouse Vice President, and Mary Yap, AWS Solutions Architect. So please join me in welcoming them both. Thank you.
Okay, checking. Got it. All right. Hey, great to see everyone. Really excited with all the speakers that we've had. Really enjoyed it, and it's great to see all of you here, especially just to remind ourselves that we're all in this and we all see that what's going to happen. We need to get together and we need to make sure that our economy, everything that we're doing here is for the betterment of Hawaii as a community and the growth and fostering of the people. So really wanted to start with this off by reintroducing my colleague Marie, who is a specialist in this area. A lot of you are probably wondering what we're going to talk about. I mean, we use a lot of buzzwords throughout, but how is this going to be applicable to what you guys are doing? And to kind of kick things off, to start with a problem, and this is a big one. And I know you guys just came from lunch, so I might make you guys feel a little bit guilty unless you finished everything in your, in your bag. But let's talk about a big problem that, towards a solution to this, actually involves a type of win-win partnership with the community and businesses. Let's look at food waste. And I want to call attention to the fact that it says food waste problem in Hawaii. So the statistics I'm about to put up are actually for here in this island. So when we think about food waste, you know, the stuff that you kind of threw away in the bag, maybe you guys didn't want it, wasn't to your taste, but we have a hard time kind of figuring out how to order that amount of food to feed a conference like this. But just in the Hawaii, 4% of the overall, sorry, I can't even see this, but 4% is usually going to be wasted by just having overpurchased, not used. 237,000 tons of food wasted on Oahu, leading to about $1 billion in waste. That's and that's again in Hawaii, leading to about 36% of the organic waste in our landfills. And we're an island nation. I mean, we're a home that has no space to like just set our stuff out to sea. We can't just be shipping this kind of stuff out, and this is a contribution that we do every day. So how do we like involve people in solving a problem as significant as this? So just to bring it back home to kind of like to what the businesses are responsible for, this is actually affecting everything that we do, not just food. Food, think of it as a resource, whether it's energy, whether it's water, whether it's people doing a service within your company. This is a significant factor towards your revenue, which talks about staffing, towards how you're going to actually plan for the next quarter coming across. So I'm going to talk about this a little bit and try to put this into a little bit more micro terms. So these are the things that we're going to face. When we think about how do I manage what I'm going to spend money on, what am I going to plan for, who's going to serve it, what am I going to do when I think I'm going to need more, or do I need less, and how I'm going to justify this. So some of this is talking about, more of like a business perspective, but let's, bring it back home. One day I'm hoping that we'll be able to invite people back over, but let's say we're going to have a barbecue. I got about maybe 20 adults I want to invite. There's about going to be 30 kids. How many hamburgers, how many buns am I going to have to get? That's how much I'm going to plan for my inventory. Because I want to get everyone fed. I want to keep them happy. I want them to have a good time, but I don't want to get a lot of waste. I don't want to overcommit to that. I don't want, people to feel that I got the wrong thing. So let me just think about how much things am I going to order? That's my inventory. Now, if I get like 30 packs of buns and I get all these hamburgers, am I going to even be able to cook all that? Do I need help? Am I going to have to ask some of the guys to come over early and start prepping this stuff a little bit more? That's the resources. That's the people that you're going to need to help make this service happen. And now if I got that much food, do I have enough space? Do I need to get another grill? Maybe I do, but because then if I'm going to have all those people, I'm going to have a bunch of people standing around, not being able to help, but maybe if I get a bigger grill, or a nicer one, maybe that's my capital investment. How am I going to make sure that this happens? But then at the end of the day, how am I going to buy something if I can't justify it? My wife's gonna give me funny looks if I buy this new grill. How many barbecues am I gonna have every year? I'm gonna have to do a barbecue of this size every 3 months to justify that expense. And so that's just your again, micro business type of thought process. But imagine this having to affect 50 businesses. What if I have 500 staff? What if I have to think about keeping them staffed in the right place, the right time, getting enough inventory to make sure that they keep their customers happy? So you can see how that kind of like plays out from a scale perspective about how am I going to predict what's going to happen next? How do I make sure that I'm not overcommitting, I'm not overbuying, but I'm also able to provide the service levels that my clients expect. So let's move on to a little bit more about how this might affect big terms as far as like my budget, my bottom line. How am I going to get better at understanding my demand? And so this morning when I was talking to my kids, they were asking me, why am my shirt tucked in? It's because I have to speak today, so what are you going to talk about, Dad? I was trying to tell them, okay, well, it's about artificial intelligence, machine learning. How do I explain that to them? So it took me a while, but then I thought, okay, well, imagine that you're walking in the grass. There's going to be footprints left. That's data. But as soon as you step away from it, it's kind of going to disappear. But if you get enough people walking in the same direction, what happens? You're going to get a path. After a while, you're going to be able to see what direction people are going in. There's going to be people that veer off to one side or the other, but eventually you're going to understand there's a pattern to the way these people are behaving. So we can't predict people. We really can't. But we can get some probability about what they're going to do. And grass, we can still see grass, we can still see the path, but data and the way people behave is often invisible. So what AI and ML really is about having those little impressions, getting the data points all together in one place to be able to say, I think this is the way that people are going to go. So with this, we brought up this study. It's from McKinsey, but they're talking about how I can increase accuracy. If I can get a 20% accuracy improvement, I can expect a 5% inventory reduction. That's less waste, and a 3% increase in revenue. Now, that doesn't sound like a lot, when you think about 20% accuracy. Number one, how am I going to get that accurate? Number two, do I really want to worry that much about making a 3% price increase or a 3% revenue increase? The answer should be yes, especially when you think about the investment. Now, I know a lot of you probably don't have a team of data analysts, but what I'm about to turn over to Marie, this is available. This is something that I kind of offhandedly asked one of my staff, and she's never really been involved with AWS stuff before. Try this out. There's a workshop. It's pretty much a formula that we can follow, that you just start up the AWS account, you follow these instructions, you load the data, and tell me what happens. And so I left her own devices. She gave me her kind of an email later on that said, okay, well, that was really interesting. It was not hard at all. I had to use my credit card to start up the AWS account, but that was pretty much the only thing. And then after that, it took me about 4 hours over about 5 days. And then I got the result, basically, that Marie's going to be able to show you. And total investment was just time. She paid nothing, even though she had to put her card in. There's a free tiering in Amazon, so there was no investment, really, other than curiosity and a willingness to try something. So what Marie is going to be showing you, and she's going to explain a little bit more about machine learning in terms that are a little bit more technical than the footprints in grass. So I'm going to turn this over to her, but I want you also to kind of think about how would I start doing this in my business? What are the use cases that I would have? What are the problems that I'm trying to address that are going to make this useful for what I do? And how it's going to affect my customers? Go ahead.
Right. Thank you, Scott. So forecasting. Forecasting is science, believe it or not. It's not like something that is a magic crystal ball that you ask a question and then you see the future. So forecasting is about the science of prediction. So what happens is that we examine historical trends, and then from there, organizations can make a decision of how they wanted to use their data so that they can make things happen and decide and incorporate this into their roadmaps. So organizations use forecasting for planning for inventory, for staffing levels, for infrastructure requirements, and at the same time, looking into various demands and capacity that is needed in the organization. So given that forecasting is very important, what most organizations are having problems with is the accuracy of the forecast. Because when you forecast too low, that means you are not investing too much, which could mean that you might run out of inventory. So imagine you go to Amazon.com and then your favorite item is out of stock. And then when you forecast too high, that means you have too much inventory. And then what Scott has mentioned, it could lead to food waste for restaurants. So how to do the proper, how to get to the proper accuracy of forecasting is what we're gonna talk about and how we can help on that. So today, companies use from spreadsheets to very sophisticated financial planning software to generate forecasts, but the accuracy is really something that is very elusive, and that is something that we'd like to help a lot of our customers solve that particular problem. So Amazon.com is a global company that ships billions of packages in 185 countries. As you could imagine, we have to determine all the complexities of buying, placement, transfers, making sure that we don't run out of space in our fulfillment centers, and also making sure that your deliveries and packages arrive on your doorstep on time. And the way that we tackle this very complex problem is through automation and technology. And so the way that we do that is by use of forecasting. So from the very beginning, the way that we invest in forecasting come into 3 different phases. So the first phase was, if you recall, Steve has put in a slide that initially we're just selling VHS. There's not a lot of variety of products that we sell in Amazon.com. So therefore, what we did with forecasting at the time is pretty much just traditional statistical method of forecasting where you're doing the average, running average of particular item in history to predict the forecasted demand. And at the time, we're just operating in a single location. But then, as the business grows, and one of the philosophy in Amazon.com is that we have a flywheel. So the flywheel is being, the input to the flywheel are the variety of products and selection, and then the more variety and products and selection gets into the flywheel, the more customers that we have in our platform. And with that, there's a lot of complex data that comes into play when we're trying to do forecasting. So at the time, we're also expanding to various countries to ship products and packages and meet our customers there. So with mid-2000, we start investing in machine learning for forecasting because of that. So with the machine learning, what it allows us to do is it allows us to forecast a variety of products and also how we do the demand in different locations. But then around 2015, we discovered that there is so much more that affects the demand of our products that is not just determined by the previous sales or the historical data itself. We wanted to solve the hardest problem. For example, what if we wanted to forecast a brand new item that doesn't have a historical sales information? How are we gonna do that? And then one other thing too is when we forecast something, we figured out that some of the accuracy in forecasting is not just determined by the traditional historical data, but then there's also like subtle relationship across different attributes or description of the products that you may not recognize it just by looking at it. So with that, we invested in deep learning. So deep learning is more of an advanced type of machine learning that looks at the different layers of data that you have. So with all the 25 years of doing forecasting, what we hear from our customers, and Kim mentioned this morning that 90% of the product that we build is based on customer feedback. So we hear from our customers that, hey, we wanted to solve accuracy in forecasting as well, but the problem is not a lot of our customers have data scientists or have invested in machine learning for such a long time that have a lot of experience around this. And this is the reason that we built Amazon Forecast. Amazon Forecast is a fully managed AI service where you as a customer, if you have like historical time series data, let's say your sales data, for example, over the past year or so, what you have to do is just bring in your data, and then Amazon Forecast is going to determine the right algorithm that would generate the most accurate forecast for your data. So you don't need to hire a lot of data scientists or be very experienced in machine learning to get the same output for high accuracy type of output in forecasting. So forecast actually has 50% more accurate than traditional method of forecasting, and it's a fully managed service. So we provision all the infrastructure that is needed behind the scene so that you spend your time bringing in your data and then analyzing the output of the forecast so that you can incorporate this into your business. So to look into an example for Amazon Forecast and how this works is that we have a fictitious company called Aloha Drive-In, and Aloha Drive-In has 77 locations across Oahu, Hawaii, and Maui. It has 51 menu items, and with so many locations and so many variety of menu items that they have, it's hard to predict with so many data of what is the demand per menu item, per location in the next 3 weeks. So the data set that we are working with is their weekly sales data over the past 3 years, and it has about 500,000 rows. So to start with, Amazon Forecast is that it only consists of 3 steps. So first is you import your data, and then you train the predictor, and then you generate a forecast, and then the output of that forecast is what you would explore your insights or visualize it in your favorite business intelligence dashboard. So the type of input data that you have in here is the only thing that you really need to bring is what you call as time series data. A time series data is basically a data that has the timestamp on when the transaction occur. Let's say this is a weekly sales transaction for Aloha Drive-In. And then you could bring in related time series data as a supplement to the time series data. So the related time series data is basically a data set where you could add additional dimensions on your sales data. For example, your sales data only shows you the menu item and then how many, let's say, barbecue beef plate that you have sold. And then the related time series data shows you that this is the location where you have sold this particular menu item, and whether this menu item has a particular coupon code associated with it when it got sold, and also if this related time series data can also have something like if you have a web page and if this particular menu item is featured on the home page. Now, there's another optional data that you can include as an input to forecast, which is the item metadata. So the item metadata is basically the grouping of your data. So for example, in Aloha Drive-In, an item metadata could be a breakfast, lunch, or dinner of a menu item, and then whether it's a breakfast, lunch, or dinner, or whether it's a sandwich, soup, or part of a dessert. So it's basically telling forecast how your data is being grouped together. The importance of item metadata is because if you're trying to solve for a problem where you have a brand new product and you don't have a historical data associated with it, you can still make a prediction of how that new item would fare out in the market and what's the future demand for that. Because the item metadata will look into the similar characteristic of that new item into the existing categories that you already have. So after you have placed in your data, you can start invoking the machine learning prediction, and it's gonna select the best algorithm for your data. And with the machine learning prediction, it does give you an explanation after the prediction that some of the variables in your data may have affected the demand. Like in this case, for Aloha Drive-In, we noticed that the base price of the menu item is the one that is driving the demand for orders. And actually, this is an example too where the promotion is not really working too well. As you can see that the promotion, emailer promotion is in the red, is at the bottom, which means that any mailer campaigns or promotion was not heavily used in driving demand for menu items that are being ordered. So, so after you have generated the forecasted output, what you can do is visualize it. And then we're using Amazon QuickSight, which is a fully managed visualization tool in Amazon that in AWS that allows you to just bring in your data and then quickly visualize it. So the first thing that you wanted to do in the forecasted output is you look into how much risk and reward that you wanted to make. So in the first table that you see in here, you have the target value. So these are actually the actual value based on in the past of how many orders are being placed for a particular menu item. So let's say the barbecue beef plate has 175 actual items that are being ordered. Now the P50, P70, and P90 is actually the 50%, 70%, and 90% demand, a future demand for that particular menu item. So if I'm a business owner and I would choose a P50, which has a value of 186 right here, that means that I'm gonna make 186 beef plates, and then there is an extra about 9 beef plates that I may not sell. But then it's a measurement of risk and reward wherein for those 9 plates that are over, it means that I have 9 plates extra and customers will always have a beef plate available. And if the beef plate is one of the most famous menu item that you have in your restaurants, you don't want that to run out because you don't want to have unhappy customers. So, but then there's also a case where you wanted to over provision. So let's say there's a holiday or something and you know that people are going more to your restaurant, then you're gonna get into the more over investing approach by using the P90 data, which is 269 right here. So one of the things is that when you click on the barbecue beef plate, it goes into the drill down, which is the table number 2 right here. And from here, we break down the next 3 weeks of forecasted demand for this particular menu item. So in case of restaurants like in McDonald's, right? Like usually you want to take French fries is one of the most commonly ordered menu item for McDonald's. So usually they would look into the P90 or the over forecast value for French fries. But then if you have, let's say, crisp apple as one of the menu items in McDonald's, it's highly perishable and therefore, and it's not heavily ordered, for example, then you would like to go into a more conservative value in forecasting it. So the other thing that we have used the data for forecasting is that we have a related time series data, which tells us like which location are selling which menu item. So we also forecasted that in the next 3 weeks at 50% probability. And then we use the geospatial map in Amazon QuickSight to show you like which one of the locations are selling the most type of menu items. So like in this case, the mixed plate is popular in that particular zip code, and the bacon sandwich is, more popular in the Kalihi area. And then the other things that you can do with the forecasting output is to look into the trends in the next 3 weeks. So here you could see what are the most popular menu items. So this restaurant is very well known for their mixed plate. And then you could also look into the busiest location right here, which is Honolulu. And if you want to look into the dashboard a little bit further, and if you want to navigate through the map and then check like which menu items are more popular in the zip code that you're in, feel free to open up your camera and then go into our demo website, which leads you to the dashboard that I just showed you. So as you can see, what happens behind the scene in that demo is that there are 3 types of data that you can put into, and most of this data are something that you already have within the organization. I'm sure most organizations would have their sales data ready. Optionally, you could have the related data and the item metadata as supplemental to your time series data. And then Amazon Forecast will take care of choosing which of the machine learning algorithm would best match your data that would generate the highest accuracy type of forecast. And then you saw the forecast explanation where it tells you like what is driving the demand of product that you sell. And then you don't really have to worry about all the steps that is seen here in the middle. That is something that Amazon Forecast will take care of you. So that's usually the items that you see here in the middle, such as inspecting the data gaps, filling in the data gaps, building in the data set, training and optimizing and tuning in machine learning model. That's something that you don't have to worry about because Forecast is taking care of that for you. So to look into real-world case studies, which is similar to Aloha Drive-In, we actually have a customer called App 8. App 8 is a restaurant, is an application that caters towards restaurant that helps restaurants know what is like the foot traffic that is coming in, so that they could properly plan their staff. And also, they also show the data for the restaurants of what are the forecasted orders for a particular menu item. So App 8 built their application around Amazon Forecast to help the restaurants properly plan and reduce food waste. Another company that is using Amazon Forecast is Affordable Tours. So Affordable Tours are basically they sell escorted tours, travel packages, cruises, and active vacations within the United States. And the problem that they're trying to solve is that they wanted to be able to give the same customer experience regardless if it is a high volume or a low volume call event. So what they do is that they incentivize when customers call in. They want their customers to call in so that their agents can navigate with their customer the best travel package out there. But then during high call volumes, there's a lot of wait times. And then it's good if there's low call volume and customer gets served right away. So they wanted to be able to make the experience much better, even like on high call volumes. They wanted to be able to properly staff the number of call center agents that's available to take their customers' call. So what they did is they work with Amazon Forecast, and they have input their data set, which is the 1-800 number call volumes. So all their 1-800 number call volumes, they import it into Forecast, and then Forecast generated an output of 5 days in advance of how much the call volume would be at 15-minute interval. In that way, they can properly staff the number of call center agents to answer the calls. And with that, they were able to decrease the missed call rate by approximately 20%. So a lot of these customers are already innovating on behalf of their customers. And if you want to know how to get started and what the journey would look like, Scott here from DataHouse would share what that adoption framework would look like.
Okay, thanks, Marie. Before I get to that, because I think we have a little bit more time, I did want to go back to this QR code in case you guys weren't able to take a picture of it. What that will do is actually open a browser window, and you can actually see the report that Marie was referencing before in the tables and all that, but also the map. So I know some of this is a little, you guys all eat at restaurants and eat food, of course, but as far as how this actually applies to your business, thinking through other use cases about how you might actually use this forecasting tool, think about like, well, how is the demand on services going to be with the return to school? If I run a clinic, if I run a healthcare provider, I know I'm going to have a whole bunch of appointments coming in because I need to do vaccinations, I need to do well child checks. If you're involved in any type of hospitality industry, what is the demand for my services going to be with recent trends and even historical trends in travel? So knowing where the people are coming from, domestically, internationally, do I have the right people in my staff that are going to be able to address language challenges? Are they coming from Korea, from Vietnam? Do I know if I have travelers that are more coming from European countries this time of year? Do I have the right level of staffing needed to address those needs? So just kind of thinking through other ways that you guys might want to populate the data, but this is, again, is a way for us to quickly relate to it, to look at how the data is actually interactive, to see how I might be able to plan not just based on demand, but also on how can I measure the effectiveness of a campaign? How do I know that this message is actually having the impact that my business wants to have because I'm getting that feedback by people calling in, by visiting the website. So all of this has practical applications, and it's available to do. So wanted to make sure that you guys had a chance to look at this again, because it's pretty cool. I mean, I am a data guy, but actually seeing the map and clicking through to see, oh yeah, beef patty, that's super available over there. Maybe I should go to that side of the island because I can never get it when I want to go to Hawaii. So just some things that to think about, but also how do I actually get started? And a lot of this, I think, through what we've been talking about is how do I turn this into actionable steps? This is always something that of interest to us because we're a technology provider, but we really are talking about how are people going to make some things happen. So after doing many years of consulting, we always like to adopt frameworks, and one of the ones that I know our AWS colleagues have talked about is the working backward. But this is something else that has resonated with people that we've been talking to. We call it the innovation canvas. I give all credit to Clyde Shiigi for really solidifying the idea and putting it into practical steps. I'm not going to turn this into the entire adoption because I think that's, this again will be something that you guys will be able to see later on. But just to kind of flash up kind of a process that we follow. This is meant to be on a whiteboard or something that you can draw on, something that you can put Post-its on and say, what are we going to do? How are we going to take that? Who are going to be involved? What are we going to try to consider so that we can get something actually done? And so just to go back to this, I think one of the things about our framework, what we talk about is the second step is what could we do? But a lot of what is made possible by platforms like AWS and these products like Forecast, you can skip that because you know it can be done. So the next thing is what should we do? What are the questions we need to ask that are going to make us successful? What are the things we need to consider to drive us forward? And so one of the other things that we talked about this morning was, well, we need to be able to plan for the next 3x. What's going to happen when we need to meet demand? What should we be doing? What should we be preparing for? How do we plan? This type of forecasting tool is something that right now I think still people feel is nice to have. But as we go forward, this tool is widely available. Anyone can go ahead and start using this. So that would be a challenge for everyone else in this room to think, when is that going to become a must-have? When do I need people who are going to have skill set and capabilities in using these types of tools, experience gathering this kind of data? Because if I'm not going to do it, then someone else is. And if I'm not going to be doing it, then am I going to be stuck in the status quo to the point where I am now the one trying to scramble for talent, trying to find my people the skill sets they need to be able to do this kind of thing? And that's not a high bar. Again, I think it just starts with experimenting. It's going to take a little while for people to get comfortable looking at the tables, looking at the charts, but it's available. It's there now. So by all means, please let us know if you guys have questions about this. The adoption framework is something that we run with our clients or prospects to just say, hey, come in. Let's talk about how we can do this with your team. Pick some folks, let's just whiteboard this out. This is how it starts. If you want to contact us, our information is going to be up there, but is there any, I think we're pretty close to timing out, but I think we have Q&A time available if anyone has any questions. Yes.
Hi. So this question is from Marie. I don't know much about forecasting until today. It seems really awesome. It seems like I work with data scientists and the modelers. It takes a whole team to do forecasting and prediction. It seems like this puts it at the fingertips. But a couple questions about the technical stuff. Like, can you export the model either as a notebook or as code at the end? And my other question is, can we take like a model that we run through and then give it actual like results? Or can we train the same model with like subsequent data sets?
So Amazon Forecast is, so the question is, with an organization that's existing data scientists and teams out there, and if they, can they reuse the models that are generated by Amazon Forecast and export it out? The thing with that is there are similar models for Amazon Forecast that's available also with our other product called SageMaker, which is geared towards data scientists. So the Amazon, and then the other thing is, could you use your own model or do a manual selection of a algorithm that you want to use for prediction? So the answer for that is yes. There are 6 models that algorithms that you can choose for that ranges from traditional statistics to deep learning type of models in machine learning. So I know it gets like a little bit technical. So the question here is for teams that have like data scientists who would like to do their own tweaks and use their own models, we have a different service that is more applicable for that one, which is Amazon SageMaker. So the forecast is really geared towards end users and developers without any data science background, because tweaking a model and creating a machine learning model is a very long task, and it requires a lot of effort. And then we're trying to simplify this for our customers so that they spend more time looking into the output of the forecast versus building the data model itself. Yes.
That's great. That's almost what I asked regarding to. It's like, I can see the value in this tool, in that you don't need that team of data scientists to actually do the prediction and build the model, right? But then, if you run it through and then, it does a prediction, and then you can correlate that with like, post factor with actual data to see if the model was accurate, right? Can we take the data set, run it through, get, the prediction, and then, feed it retroactively, like the actual data, and then tweak that model that way?
Yes, so his question is that, let's say the first time you put in your data, you are not satisfied with the accuracy of the forecasted output. Can you go back and then tweak the model, which means that you could adjust some parameters on the model itself to make it more accurate? So the answer for that is yes. There are some options for you to tweak the parameters to make sure that the forecasted output is what you expected with the accuracy that you're looking for. Yeah. Yeah. All right. Any other questions? Yes.
So this ML, is it on AWS server, the tool that you're talking about? If my company have AWS server, can I use the tool?
Yes, so Amazon Forecast is one of the services available in Amazon Web Services. It is part of our AI service. So Amazon Web Services has a lot of AI type of service. One of them is Forecast. There are other services that is in line with Forecast. We have like Amazon Comprehend, which does like natural language processing. We have Amazon Lex, if you want to build like chatbot. So you can easily build chatbot as well. And then we have like a translator type of service as well, and among others. So yeah, you can open up an AWS account, and then there is a free tier for Amazon Forecast. Like what Scott mentioned, they tried Amazon Forecast, this particular demo, which cost nothing because it fell under the free tier.
Good.
One question. But our data is on SharePoint, and SharePoint is on AWS cloud server. Is there any way that I can connect the data from SharePoint to use any of your forecasts?
You can move data from SharePoint to AWS. There are services that, or you could copy your data from SharePoint to AWS if you, so the question is, they have SharePoint on AWS already. So, and would they be able to use that data in SharePoint with Amazon Forecast? So the answer is yes. You can copy your data from SharePoint to what we call like Amazon S3. So Amazon S3 is another storage device that accepts data in different format and from different sources such as SharePoint. And once the data lands into S3, it can automatically be integrated or imported into Amazon Forecast. Yeah.
One final question.
Yes.
Were you able to like do a cost analysis of how much it would cost to get like, you know, consultants to do that prediction and build that model versus like me who owns that business uploading the data and running it?
So there was a question of how much would it cost to hire data scientists and consultants versus to just using the service. So cost is, what I could tell you, we have not created a model for that, but what I could tell you is for Aloha Drive-In that has 500,000 records and 77 location and 51 menu item type of prediction in the next 3 weeks. And then with the visualization tool, it costs like less than $50 a month to do this type of prediction. Can you imagine spending $50 a month and being able to properly forecast the demand of like which menu item is most gonna sell out and then prevent food waste, right? So what Scott has shown you in the very first slide, like 4% of the profit of restaurants are actually gone because of food waste. So imagine the savings that you have with 4% of sales revenue that's added back to you, and then by spending $50. So, and we have also, the pricing is very transparent. So Amazon has a pricing calculator that is available online. So if you search for AWS calculator and then select for forecast in there, then you'll be able to model out how much it would actually cost per month. And there was a question.
And sorry, and just speaking as a consultant. So I think what's great about having these types of products available to clients is that they get to experiment first. They get to bring their data into it, start trying these things out, and that by the time you even spend any dollar of money on a consultant's time, you actually have a new place to start the discussion. To say that, here's the kind of data that we have available. I think that's one of the things that as a consultant we usually do a lot of requirements work is to say, okay, what kind of data do you have? we spend a lot of time doing that, actually. It's like, okay, well, you have data here, 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 and here. We're going to need to consolidate that, pull that in. And so a lot of it is not necessarily maintenance, but it is a lot of gathering. And so part of having this available to you is you start familiarizing yourself with the concepts of what type of data, how much data, how to format it, and how am I going to get an opportunity to actually start looking at this thing. So I wouldn't say that we have like a cost model to that will say like, here's how much return you're going to be able to get by employing us for 50 hours to be looking at this, because every client is different. They have access to different data. So it's really hard to say like, okay, well, here's the package A and it's going to cost this much. But I think what's very helpful about these types of tools is that you've already started your own learning. You've already started putting this into your organization. And by the time you come to us, you actually probably have a team at that point who's already said, well, I've already looked at this. What can I do differently? And I think that's a much more valuable conversation to have than to say, sit back and watch these guys do something and produce a result, and then, hopefully they'll train us at the end, and we would, but I mean, you know what I'm saying? I think that's what we're trying to promote. It's, we're not trying to get ourselves less work, but I think it's like we want to try to be the most value.
No, I totally agree. Like understanding how or what to analyze and what data types you need and data sets you need is really important.
Yes, it is.
More important, as important as the algorithm itself.
Thank you, Scott. We have, and Marie, we have 10 more minutes, and so I see there's one question over here, and there might be another one over here.
My question kind of relates to that, with the data. I know this wasn't the crux of this presentation, but how do you guys deal with non-perfect data? In our case, a lot of our customers have that, and it's either a non-starter or it's us feeding them. They get it so we can even start off. And this is a common problem we have. Maybe your guys' customers are better, or maybe you're smarter dealing with this particular issue.
So the question was about the get data part. A lot of times that is the first hurdle, is where am I going to get enough information to start basing this on? And so I'll just kind of like handle that a little bit. It's not that we have clients who have a wealth of it. It's more that we know that there's places to get it, and here's how you're going to have to start gathering it. So it might not be that you can start from scratch, like just gathering it through web data or analytics, things like that. So it might be, where else can we start looking for information that is actually public? So I'm not sure which the industries that you're involved in, but like when I talked about visitor statistics, Department of Business, Economic Development, and Tourism, they put huge data sets available online. So what are the questions that you're trying to answer? What are some available data sets that we can borrow or to start with? What do you have now, and where do we start needing to augment that? Some of it, again, kind of catch-22 because you want to measure something that you don't even have data to support yet. So what are the things that we're going to need to start measuring now? It's kind of a high hurdle because, as Maureen noted, 100, 200, 300,000 rows of data, that's a lot. It is. So there is some level of that where the best thing that we can do is just start spreading this message now. To just say, okay, what's going to be important to you? Let's start trying to put some measurements on that. How do we understand a little bit better about how your clients are interacting with you? Do you have a point of sale system that's already in place? Maybe you don't own it, but can we work with a vendor to start gathering and collecting that? Because that would be a natural next step. Or where else can we borrow this kind of information from? Because it's going to be helpful in our discussions. So yeah, it's not an easy answer. It really depends on where the organization is. It's not like we select our client based on how much data they have. It's never enough, really. So it really is about, okay, what are you trying to solve? What can we start with? What can we seed it with? And what other things do we need to do in the meantime? So while we're continuing the discussion, we're already starting to collect. So I don't know if that really helps too much solve it, but that's kind of what we help people at least start talking about, yeah.
We have time for one more question. I'm just scanning the room here.
Related to that question, is there a minimum level of sanitation for data that the forecast needs? Like, does it handle? Like, I mean, there's different algorithms. It looks like, right? Does it handle this data? Or how clean does the data handle?
Yeah, so the question is the quality of data. If there's like a minimum number of rows or quality of data. So there is a feature in Amazon Forecast that if you have, let's say, sparse data, for example, it's not a problem for Amazon Forecast. What it does is that it gets more of like the median or the average value of the neighboring data points to fill in that missing data in your data set. That's one thing. But yes, you do need to, everybody might have their own, most of the data that you put in Amazon Forecast are usually your transaction data that is most probably be in one of the databases that you already own. I'm sure everybody would like to keep their sales data at some point, and and inventory data, right? So what you could do is just do a quick export of that one, and if you do need tools to help you export that data from the database, AWS also has a lot of tools that makes that easy for you to extract data from various databases and then put it into Forecast. The other thing that I wanted to bring is that if you wanted to enrich your data with other data sets out there, AWS also has what we call like AWS Data Exchange, where we publish a lot of like public and proprietary data sets in there that you can use to look into like macroeconomic trends of a particular data set that you wanted to incorporate with your existing data. So yeah, so there's a lot of data out there. We can help you find it. Yeah. And Scott?
And just to add on to that too, one of the other things about machine learning, right, is it's a machine. It needs to consume things in a format that it can recognize. And so when you think about that, data quality does matter. But some of the other services that Amazon does provide are things like Textract, which are going to turn your documents into data. So if you have a lot of paper and you want to go through a document scanning process, a lot of that can be turned into usable data as well. So you may not have a large historical trend of data, and you might have some data quality issues, but there are definitely some products and solutions developed around there to kind of address that. So yeah, I think that kind of goes beyond a little bit of the forecast part of things and goes into like a different type of data ingestion and management. But we've dealt with quite a few of those types of products as well to try to fill the gaps where we can.
All right, well.
One yes or no question. If I'm Aloha driving and you guys have worked with me for years and I provide you a nice set of good macro trends, Mahalo driving opens up using your tools. Do they have any access to my trends? Is that going to weigh in any way at all?
Well, if you have your own data, no, because everything is search.
They use macro trends, you know.
Oh.
So is my data that's on Amazon servers going to go into my competitors' decision making?
So the answer is no. So your data is what you control, and the moment that you put in your data into Forecast, it is encrypted and only be accessible by you. So Mahalo Drive-In will have their own data set and will need to train their own models as well and tweak it to their advantage, yes. So, all right, well, thank you very much. Thank you for all your questions. Thank you.